Alright guys, so nothing surprised. Today we're gonna do some AP practice for the chain rule and something related to the product rule and the quotient rule. And even we can dig into the implicit derivative, but I think we're still not too far yet. Alright, let's do the first one. If f of x equals parentheses x squared minus 3 raised to power of 4, then f prime of 1 equals to what? So f prime of x it should equals to 4 times x squared minus 3 raised to power of 4 minus 1, which is 3, and times the derivative of inside function, which is 2x. And the derivative is 8x times parentheses x squared minus 3 raised to power of 3. We plug in the 1 to the function, becomes to 8 times 1 minus 3 is -2, -2 raised to 3 is -8, and what we got is -64. So this one we got A. All right, next one, we gotta use the chain rule for this one also. So y prime equals to 5 times x over x plus 1 raised to power of 5 minus 1 is 4, and times the inside derivative of inside function, which is the derivative of x over x plus 1. And then we simplify the equation, which y prime equals to 5 times x raised to 4 and x plus 1 raised to power of 4 times. This one we use the quotient rule. What we got is x plus 1 squared, x plus 1 times derivative of x, which is 1, and minus derivative of x plus 1 times x. The derivative of x plus 1 is 1, so 1 times x is x. And we cancel out each other. So we got it's y prime equals to 5x raised to power of 4 time over x plus 1 raised to power of 4 times 1 over x plus 1 squared. And because it's a multiply, so the denominator just the power of denominator should be add together. So the final answer is 5x raised to power of 4 over x plus 1 raised to power of 6. So we got D for this one. All right, the third one, if f and g are twice differentiable functions such as g of x equals to e raised to power of f of x, and g double prime of x equals to h of x times e raised to f of x, then hx equals to what? So we do double prime of gx, so we do the first derivative of gx, g prime of x equals to f prime of x times e raised to f of x, and g prime of x equals to f um second prime of x times um e raised to power of x, and plus f prime of x times e raised to f of x, and times another f prime of x. So this one we got in the original derivative. Because it's a product rule, we have to do the first derivative times second origin, and plus second derivative plus first origin. So we do is so we do this derivative of e raised to power of x again, and f prime of x here it's keep as usual. So we got its f prime double prime of x times e raised to power of x plus f prime of x squared times e raised to power of x, and we factor it. What we got, h of x should equals to f prime double prime of x plus f prime of x squared. So for this one, we choose um E. All right. The next one, if f of x equals to e raised to tangent square x, then f prime of x. So this one is really classic. I mean the general question. So we do the general for exponential function, and especially the base of e. So this one gives us a tangent square x prime times e raised to tangent square of x. And the prime of tangent square x becomes um the becomes to tangent of x square prime. So it becomes 2 times tangent of x times tangent of x prime, which is 2 tangent x times secant square x and times e raised to tangent square x. So for this one, we choose D. All right, the last one. If f of x equals to e raised to power of 2 times x, then f prime of x equals to what? So f prime of x equals to, we use the chain rule, and it becomes to 2 over x prime times e raised to 2 over x. So 2 over x prime equals to 2 times x to negative 1, and we do derivative of it, and times e raised to 2 over x. So we got it negative 2 times x raised to negative 2 negative square times e raised to 2x. So what we got is negative 2e raised to 2 over x squared. So this one we choose D. All right, here's daily video today about the chain rule and more something deeply about chain rule. Hope you guys enjoy and see you guys later.